Okay, so good morning, everyone. This is Ravi Prakash. I am Head of Architecture and Tech Ecosystem at Foundation for Interoperability at Digital Economy. It's good to be back. Hey, Jose. Hi, Jan. And well, let's begin. So I'm sure some of you must be wondering why this weird title of the slide, 0.85 to 1. We have all heard of Peter Thiel's 0 to 1 thinking, right, which refers to creating something completely unique rather than making incremental improvements to existing things. But what do we mean by 0.85 to 1? Some, I don't know if there are space tech enthusiasts or space technologists today, maybe getting the clue from the image that is there. But anyways, we will cover that in this presentation. So, so to understand that, let's just probably just take a step back and look at a couple of conversations maybe in the near future between Lisa and Adam. Lisa is a smart city or a smart country planner. Adam is an AI agent. And it's the year 2200, and Lisa has detected something very unusual. So, okay, so Lisa basically detects something unusual and asks Adam, hey, we have received some alerts from ISRO satellites indicating some energy spikes in downtown Bangalore and in New Delhi. What is causing these spikes? And Adam says, hey, the energy spike in downtown Bangalore is due to excess data center usage, and in New Delhi it's because of increased EV manufacturing and usage. Okay, Lisa says, thank you. What are your suggestions for addressing these issues? So Adam says, to address these energy spikes, I see the following. So we can probably implement some data center optimization strategies to reduce the energy consumption. I consider using NASA's 3D supercomputer to calculate the satellite trajectories for energy redirection. The estimated cost for the service is somewhere around $18 million. In New Delhi, we can implement EV charging and infrastructure upgrades. This includes deploying some downtown, solar robotics with Tesla's robotics, and utilizing SpaceX satellites to, again, redirect energy. Or we can also consult MIT for optimization, techniques, do some R&D, and also utilize the Siemens digital twin service, to simulate and emulate some of these strategies, right? And the total estimated cost is somewhere, around $98 million rupees. So Lisa says, hey, that's quite a bit of investment. How do we achieve this? So Adam comes around and says, hey, to secure funding, we can identify some potential sources. Some of them could be municipal budget allocations, some could be energy efficient grants, some could be even public-private partnerships, right? And it'll continue monitoring these transactions and keep Lisa updated on the status, right? If you have any further instructions, please go ahead and let me know, right? Now, this is a conversation which was generated by ChatGPT yesterday, evening, right? Which means that if you can think it, then we can probably do it. So it seems sort of achievable, right? Doesn't it? So let's probably go fast forward, probably take a trip down, the future lane and sort of identify some things that we have discovered about our civilization, right? In 1964, Nikolai Kardashev created a theoretical framework to identify how advanced a species is, right, to the level of advancement of human civilization on the basis of how much energy it consumes, right? In that, he proposed 4 or 5 types of civilizations, namely type 1, type 2, 3, 4, and 5. A type 1 civilization is a kind of civilization that's able to harness all the energy that is produced on its home planet, right? And a type 2 civilization is able to harness all the energy produced by its host star. It generally sort of requires the construction of some sort of mega structures that, like Dyson spheres or Dyson swarms that sort of captures all the energy and retransmits it to its host planets. And scaling this further, type 3 is able to harness the energy of its host galaxy, a type 4, the whole universe, and so on and so forth. Type 4 and 5 are very hypothetical. We really have no clue of what kind of a civilization a type 4 or 5 would be. So let's probably restrict our discussions to type 1 and 2, right? So just to give you a sense of the scale at which I'm talking about, this is an image of a Dyson sphere. It fundamentally redefines what scale is, right? It's this super mega structure that represents a quantum leap, right, in the advancement of our species, and the structure is not a pipe dream anymore. Several papers have been published on what it takes to build a Dyson sphere or a swarm. Okay. So we saw the scale, type 1, type 2, type 3, and type 4. Where do you think humans lie? Any Any guesses? Yes. We are actually at type 0.85, right? As per some of the some scientists believe that based on our technical advancements, we are around a type 0 or a type 0.85. We're close, but we're not there yet. Right? So over the last few decades, we have seen an explosion of innovation, right, through various, in various areas of science and technology, like, reusable rockets, artificial intelligence, generative AI, ion engines, digital twins, satellite internet, and recently I just read about something called as an interplanetary internet, and a low latency sort of internet that we are currently, proposing. Now, we as a species are now, it looks like we are getting to know more and more about the universe each day, from the largest to the smallest. Now, how do we move from a 0.85 to a type 1 civilization? It looks like we are not that far, and that's the title of today's presentation. Now, if someday we were to build a Dyson sphere or a Dyson swarm or anything, to achieve such a status, we need to fundamentally reimagine how problems are solved at a grassroots level. Right? And it's clear that it cannot be done by one person or one country. This requires an unprecedented level of collaboration and cooperation between countries and businesses, between ourselves as a species. Right? The first step to achieve large-scale collaboration requires all resources like knowledge, material, machinery, skills, financing, services, etc., to be accessible on a common infrastructure. So that someday maybe a student sitting on one corner of the world can build a solution to every problem that we face today with AI agents and digital twins today. Solutions can be created, theorized, tested, and simulated on digital twins and quantum computers, and quickly implemented at scale. Now, over the past 2 years, Beacon Protocol, a universal resource discovery and fulfillment protocol, has seen the emergence of networks such as ONDC, that allows access to material, or I would say products, and logistics and financial services. Honest is a network that allows you access to skills and services, to jobs and courses and education, right? UHI, the access for healthcare, UEI for access to energy producers. And today, all of these networks are interoperable, which means that using a common API, a common infrastructure, or common application, you can access all of these services seamlessly without any integration overhead. Now imagine if all the resources like quantum computers, time on satellites, space telescopes, research labs, digital twin services were available on a common network. It would be a step further towards a world where conversations like the one we saw in the beginning are possible. So in conclusion, I would like to encourage the vibrant space tech ecosystem, especially of India, which is emerging, to collaborate on a common sort of, on a fabric to help solve some of the fundamental problems and get us closer to understanding, and understanding and solving some of the problems, that we currently face today, right? Because to achieve what it takes to build a type 1 or a type 2 civilization, some very fundamental problems need to be solved, right? And to make things a little more practical, I would say, as a first step, all the the satellite companies, the space, launch companies, the analytics services, even the compute services can all come together on a common network, allow for research and development institutions, R&D like ISRO and IITs and the ISEs to access these resources on a common fabric, run their simulations, and actually help solve some of the fundamental problems that exist today. So maybe if we do that, right, we can achieve a point where we are able to understand where we are, where we are going, and maybe, if possible, even understand why. Thank you.